We're working on some problems here from the continuity section in Module 2 for Math 181. It says the first one, determine the set of x values where y equals x plus 7 over x squared minus 2x minus 8 is continuous using interval notation. So what would make it not continuous is if we were to have, let me get to the right color, there we go. If we have a 0 in the denominator, and so we want to factor the denominator, there's x squared minus 2x minus 8 is x minus 4 times x plus 2. So if you look for x minus 4 being 0, that's where x equals 4. And x plus 2 equals 0 whenever x equals negative 2. So these values we have to exclude. Must exclude these. So it's going to be continuous from negative infinity to negative 2. And I got a parenthesis at the negative 2 because it can't be there. Union negative 2 to 4. Union 4 to infinity. So that is the continuity question there. I took these a little bit out of order. So the next one is number 3. That was number 6. And this one says a function f of x is said to have a removable discontinuity at x equals a if f is either not defined or not continuous at x equals a, and if f of a could either be defined or redefined so that the new function is continuous at x equals a. So we have f of x equals 2x squared plus 6x minus 80 over x minus 5. So it says show that f of x has a removable discontinuity at x equals 5 and determine what value for f of 5 would make f of x continuous at x equals 5. So if you recall from your pre-calculus days, we could probably factor this out. That's my guess. So we're going to have, so my point is I'm betting x minus 5 is a factor. Let's just check and see if that's the case. So if we said x minus 5 was a factor, the other one would have to be 2x plus 16. Where do I get that? X times 2x is 2x squared. Negative 5 times 16 is negative 80. So we just double check now. X times 16 is 16x. Negative 5 times 2x is negative 10x. That does make a 6x. Okay, so that worked out. All divided by x minus 5. Now if we were to factor, we've already factored, if we were to divide out the x minus 5s, we're left with 2x plus 16. Now technically there's still a hole at x equals 5, even though we were able to remove the discontinuity, that what would have been like a vertical asymptote, we could remove that from there. The 0 in the denominator's been able to be factored out and divided out. What we have to do, we have to acknowledge there's still a hole there. But if we looked at f of 5 in this case, that's 2 times 5 plus 16, which is 10 plus 16, which is 26. And that's the answer.